Hello everyone. Today we are going to learn about a new React hook, which is the useMemo hook. You might have already heard that React re-renders components based on state or prop changes. But sometimes re-rendering can cause unnecessary performance issues as well. And that is where useMemo comes in to help optimize our applications. Before we jump into this, let's understand what memoization is and why it's so useful. Memoization is an optimization technique used to speed up programs by storing the results of expensive function calls and returning the cached result when the same inputs occur again. This is not something that is unique to React. Memoization can be used in any programming language. Let's look at an example using plain JavaScript to showcase and understand what memoization is. So here on the screen, you'll be able to see a script. Here I'm mocking an expensive calculation. So whenever we call this method and pass a number to it, it will log calculating using num, the number that we are passing. And then line number 3 is an empty for loop. And this for loop executes a very long loop to mock something that requires a huge amount of processing. Assume that we are iterating over a large list and performing some operations before returning a value from this method. And ultimately, we just return the square of the number that has been passed. So if you put 2, you'll get 4. If you put 5, you get 25. Now, in terms of a function which is memoizing this expensive calculation, how do we memoize it? So we created an object called cache, and this method, whenever called, returns another method that has the same call signature as the expensive calculation. So you will pass the num for this method as well. And what it does is it validates if the cache that we are creating already has an input matching to the number that we are providing. It will log fetching from cache and return the response that is already stored. If not, it will perform that expensive calculation and store this in our cache. So cache for number 5, 6 or whatever number we are passing will store the result that comes out and it will return the result once again. So this is how a function memoization looks like. Now what we are doing is we are calling this memoized calculation method that we've created, and this in turn gives us this method which has the same call signature as expensive calculation. So instead of calling your expensive calculation, we will be calling this memoized function. Now first let me comment out these 3 lines because I want to showcase how this method runs. I'll run the script and here we can see it's calculating using num5 is the value that we are passing to our memoized function. And we are using console.time to time our functions to see how much time it takes to run these methods. So we started and we got the outputs of memoized function, which is 5 into 5 is 25. And the call took around 4 seconds to complete. Now let's uncomment this and run this. Now in this one, we are again timing it and calling it with the same value. So ideally, if our memoization is working, it should check. In my cache, I already have the output for number 5. I will not run this expensive calculation again, and instead, since cache num exists, I will just return the output of the value. Let's press enter and see how much time it takes. And here it is. It only took 0.29 milliseconds versus the 4.6 seconds or 4651 milliseconds it took for the first time. So we see it's more than 10,000 times faster this time because we are memoizing the calculation. So this is how function memoization looks like and why memoization is used in general in coding to optimize our function calls and make them faster. Now let's jump back to understand what useMemo is. With the understanding of memoization, it would become a lot clearer and you'll be able to grasp the concept very efficiently. So useMemo is a React hook that allows us to memoize the result of a function or calculation that we are doing on our component so that it doesn't recompute every time the component is re-rendering. So when implemented, React will only recompute when one of the hook's dependencies change. Let's have a look at examples to understand that a little better. So here is our component where we will see the first use case of useMemo. Let's look at the component, try to understand what the problem is and why useMemo is useful here. And then we'll update the implementation accordingly. So this is a simple form component. It has 2 states variable, an input value and a submit count. Input value is tied to text box. So whenever user enters something in the text box or updates it, it will be updated automatically. And then there is a submit count. Whenever user clicks on the submit button or triggers a submit event on form, the submit count will increase. Here we have a dynamic form object which controls the button label and the state of the button. So whenever input is a non-null or non-empty value, the button should be enabled, and we change the label of button from disable to submit. That's what it's doing. Now in our use case, there is a requirement that whenever form configuration changes, we need to tell form config has changed, call a script and send the form config there. For now, I am just mocking it using console.log. And here is our submit handler, which increases the submit count by 1 every time the button is clicked or a form is submitted. Let's have a look at this component. Here is the component. And on initial load, you would see the use effect is triggered once, which tells you, okay, form config has changed. This is the current form configuration that we are sending to our script. So great, component initialization is working. Now let's type something. And here we can see for each update, form config was called, which is also good. The expected behavior form config is changing because it depends on input value. So every time user is inputting something, we are sending the data. But have a look at this. I clicked on submit. Now the form state did not change because on submitting form, I'm not changing the state at all. But still we can see every time I'm clicking on submit, my use effect is getting called again and again and falsely submitting the analytic script that form state is changing, even though it's not. And that's where referential equality comes into picture. So in JavaScript, all the objects are of reference types. For example, we have form config and form config 2. Even though both of them have exactly the same value, these are not two equal objects. In JavaScript, if you do form config is equals to form config 2, it will return false because these are two different objects for JavaScript. And that's where this use effect comes into picture. This use effect is tracking whenever form config is changing, please run me. But whenever we are changing the submit count, the component re-renders. The entire component runs once again and form config is initialized once again. So whenever we submit the button and change the state of submit count, this form config is initialized again during re-render. And because of referential equality, the new reference that is created is different from the old one and the use effect keeps on running. This is incorrect. And how we can fix this is we can memoize this object. So let's implement useMemo here. First, let's put the return value in parentheses, just to be very clear. The call signature of a useMemo hook is, so this is the call signature of a useMemo hook. UseMemo hook takes a callback function which should return a value and a dependencies array which is very similar to what we do for useEffect. So whenever this dependencies array changes, only then this callback will be executed and the value that is returned from the callback is taken as an output of the function. It will be memoized corresponding to the input that is provided. So here our input becomes input value. Now we are explicitly telling React that form config is dynamic, but it should only depend on input value and not any other variable in our component. Let's see if that fixes the submit count issue. I'll go ahead, refresh it once again on a fresh one, put the same string, check, use effect ran 5 times whenever input changed, which is expected. Now let's go ahead and submit the form and see if the issue comes up again. And here we can see on submitting the form, we did not have form config come up again. Let's clear the console to see it very clearly. I'll submit it once again. You see, on submitting, even though the component is re-rendering, you see this 2 gets updated. The component re-renders, but it does not trigger the use effect at all. And it is because of useMemo. So now, whenever the submit count changes, it knows I do not have to reinitialize the form config or make any changes there, and it does not create a new instance of form config. And that's how a faulty retrigger issue is resolved now. This is a very common use case that you will encounter in your React components. useMemo can solve it very quickly. And this was the first implementation of useMemo to check for referential equality and inequality and initialize some of the declarations appropriately. Let's go ahead and have a look at the second common issue that we will see and how to resolve that. It is very similar to the example that we saw for memoization, and we'll re-explore it in terms of React components. Let's look at our second example now. In this, let's look at the UI first. Here is a table which contains a list of employees. There are certain columns to see. So if I don't want to show experience, city, or work stream, I can choose these switches and they will go ahead and hide the appropriate column for me. Here we can see. And then this also allows you to search for employees. I can search Bob. It takes some time, but it gives you the result ultimately. Now let's look at the code for this. Also, one call out, the data will keep on changing because we are generating it dynamically. So from refresh to refresh, you might see the data change a little, and that is okay. So you see the data changed. Now looking at the code, we can see we have a method called perform complex operations, where we are getting some data from an external source. Then the search term is the term that we put in our input box and search our data appropriately for the term, whether it's included or not. And then the sort configuration. So you can sort by name and other things. So right now, by default, it will be sorted by name. We are slowing down the calculation, or we are mocking the situation where we might have to do a lot more calculations in this method by just running an empty loop. So we slow down the function call whenever it is invoked. Now let's look at the component. We don't have to go into the search filter form and sortable table. I've extracted them out. We only need to worry about what's going on in the employee table. Here we see we have 5 state variables, and those are search term, which we track at the input box level, and then the 3 Boolean variables which control the visibility of the 3 columns, the experience column, city column, and workstream column. So you can toggle their visibility using the switch buttons that we saw on top. And then there is a sort configuration, which will be used to sort your data. So by default, it's sort by name. And this is the handle sort method. And this here is the filtered data that gets plugged into the table to be shown on the screen. Now, what happens? I'll go ahead and change one of the flags. I'll click on the show experience. We see that operation took a significant amount of time. And that is because, again, whenever a re-render is happening, React reruns this complex operation again, even though the operation we are trying to perform does not change anything related to data. Just to see that it's actually happening, let's add a use effect. This use effect that we see will log filtered data changed every time the filtered data changes. Let's have a look. So here, initially it logs 2 times because the data is rendering, and then I'll click on show experience. And we see it showing filtered data change once again. And that's happening because this perform complex operation runs on every re-render. Now let's use useMemo to optimize this. Let's import this. And here we will return the response from this perform complex operations. In dependency array, this should be updated every time data, search term, or sort config changes. So now, as per the use memos implementation, there is a callback method, and this callback method will return the value of perform complex operations method here, which is mocking the slowness. And this only depends on 3 state variables, which are data, search term, and sort config, and will not worry about show experience, show city, and show workstream changing. Let's see if that fixes the issue. I'll refresh and let's change. We see the operation is more or less instantaneous now. So I can click on them and the data shows and hides visibly. And only when I'm changing something, searching for Bob, the filtered data changes and it shows you the appropriate result. So the slow operation or the computation heavy operation is now being memoized and only changes whenever we are actually changing the data. And so now, as we can see, our computation heavy function is being memoized and it will not be impacted whenever our other state variables are updated in our component. So what we have done here, we have used useMemo to memoize or perform complex operations method. So here, because of useMemo, function will only be executed when data, search term, or sort config changes. If we toggle the visibility of the columns, this won't trigger a resort or search, making the component much more performant. All right, now we understand both of these scenarios. One where useMemo is very beneficial when you're dealing with referential inequalities and equalities. And the second one where you have to memorize a very complex operation or complex function in terms of inputs and outputs and streamline it so that it does not run every re-render because of other state variables. Now, with this in mind, we also need to be aware that we should not overuse it. We've seen that it can really optimize your performance by avoiding unnecessary computations and re-renders. But memoization isn't always the solution. Overusing useMemo in places where it doesn't provide a significant benefit can lead to unintended consequences, specifically increased memory usage and added complexity. So, we should always ask whether the calculation is really expensive, which we are trying to memorize, whether the memoized value depends on state props that changes frequently, or will memoization reduce unnecessary re-renders or recalculation. If answer to these questions is no, we don't need to memorize it and let React handle the updates by itself. It's very efficient that way. Hopefully, this session gave you context into how use memo is used. What is it? What is memoization in general? So in next sections, we'll try to explore more performance optimizations and hooks in React. But one thing to always remember is optimization should come after identifying a performance problem, not before. That way you might be solving for something that not even exists. See you in the next one. Have a great day.